this video, we're going to talk about how to solve a system of equations using linear combination. So for linear combination, we're looking to organize our equations in what we call standard form. What that means is that you're going to have the same variables lined up. You can see that the first system that we're given here of 10x plus 3y equals 93. You have the x, you have the y, and then what it is equal to. The second equation, 5x plus 4y equals 49. You could see that the x's are lined up. You can see that the y's are lined up. You can see that the answers, or just the number values, are lined up. So for linear combination, what we're trying to do is to make one of the coefficients for the variables match the other one. What I mean by that is I want, for the first one, if I look, I want to try and make 10 and 5 look the same. So what would I multiply by to get them to look the same? Well, I know that they're both multiples of 10. So if I multiply this second one by 2, 2 times 5 is 10. Now, the other thing that we want to take into consideration is that we want one to be positive, one to be negative. So if I have a positive 10x, I'm actually going to multiply this second one by -2 to get to negative 10x. With a linear combination, you want to make sure that you are multiplying the entire equation. So let's actually do that. -2 times 5x is -10x. -2 times 4x is -8y. -2 times 49 is -98. The first equation is going to stay the same as it was here. All right. And when we do linear combination, we're really just looking to combine the two equations. So 10x minus 10x, oh, that equals 0. It goes away. It doesn't have a value. 0x is equal to 0. Then I move on to the next one. I have a positive 3y minus 8y. Well, that is -5y. And then I have 93 minus 98. Well, that is -5. -5y equals -5. Divide by your -5, that coefficient. And we learn that y here equals 1. Once you have one of the variables, you can go back, substitute it in, and solve for the second one. So if I use that first equation, you could use either equation. 10 times x, that's what we still need to figure out, plus 3 times 1 equals 93, plus 3 times 1 is 3 equals 93, minus the 3, minus the 3, 90, divide by 10, divide by 10, and x equals 90 divided by 10 is 9. Again, we write it as a coordinate, x first, 9, 1. We can substitute the values into the second equation and make sure it works. We can also use our calculator, our graphing, and graph both of those equations as original equations. So 10x plus 3y equals 93. 5x plus 4y equals 49. And we will see that it intersects right here at 9, 1, the coordinate 9, 1, which is exactly what we thought it should be. The second problem that I have here looks maybe a little bit more challenging, but it is still going to use the linear combination method to solve. So what makes the second equation or the second system a little bit trickier is we actually have to multiply both equations. If you remember when we did this first one, I used 10 and 5x. And I'm like, okay, 5 times 2 is 10. But if I look over here, 2 doesn't easily multiply to 5. 2 doesn't easily multiply to 3. So I need to multiply both equations. It doesn't matter which variable you're trying to eliminate. I try to eliminate the first one just for my own personal preference, but you could eliminate the y's if you'd like. So what I'm going to do here, I'm going to eliminate the x's again. So 5 and 2, what is a common multiple of 5 and 2? Well, that's 10. So I'm going to multiply the top by 2. Again, you multiply the entire equation by 2. 2 times 5x, that's 10x. 2 times 2y, that is 4y. And 2 times 0, well, that's still 0. All right, and I got to make this 2x become a 10. So I'm going to multiply by 5. 5 times 2 is 10. But again, remember, we need one to be positive, one to be negative. So I'm going to make this -5 when I multiply. 5 times -5 times 2x is -10x. -5 times, and you take that sign in front of it, -3y. That's a positive 15y. And -5 times -19 is going to be a positive. It is 95. And now I get to the linear combination. 10x minus 10x, it's gone away. Sometimes I used to teach this calling it the elimination method because you're trying to eliminate one of the variables. And then I have 4y plus 15y, well, that's 19y. And I have 0 and 95, well, that's going to be 95. Again, this is a one-step equation now. 19y means 19 times y, so we do the inverse. (95) divided by 19 is 5. All right, so we have found what y's value is. And just like we did before, once you find one of the variables, you're going to go back, you're going to substitute it in to get the second variable. All right, so you could use either of the equations. I'm just going to use the top one. So 5x plus 2 times 5 equals 0. I took this equation right here. And where I saw y, I'm now putting that 5 in. 5x plus 10 equals 0. Move that 10 away. 5x equals -10. Divide by my 5. And I get that x equals -2. Again, write your answer as a coordinate. X first, -2, 5. And I could substitute both of those into the second equation, make sure it works. I can also visually see it by graphing. If I type those two equations in quickly, 5x plus 2y equals 0, 2x minus 3y equals negative 19. And if I go right here, I can see that their intersection point is negative 2, 5. And that is exactly what we predicted.